This conference will now be recorded.
Obviously you can.
Got it. Cool. Yeah, so we can go and get started. Let's see, we've got the link to the Google Doc down in the chat so folks can sign in. You can see we've got a couple of main things today, the Global Summit, prepping for that and kind of reviewing with everybody. And then the overview of the Arista 7368X, which Narayanan will be presenting from Arista. Cool. I guess, yeah, let's just go ahead and jump in. Hopefully everybody has seen the, if you haven't already, the call for papers, or not paper, well, papers also, but also speaker talks went out. Currently, Scott, Shin and I have been talking with OCP, the coordinators, to try to understand, like, hey, how many tracks will networking go for this time? In the past, we've had, well, a couple times ago we had 2, and then last year we went, last couple years we've gone to 3. So hopefully everybody, just like last year, fill out, submit a talk. The link for the talk is, to submit one is in the notes. And then we'll start sort of understanding what the overall breakdown is of talk topics. Scott, anything else you wanted to go over with that?
So yeah, one of the things that OCP asked us was not just the number of talks, but the format of the talks. And they were asking, like, do you want like a lecture type of seating, or do you want a more like a workshop where you have, round tables and, everybody's kind of sitting around talking with each other? And so we just by default kept it like we've had it before, which is this lecture style talks, where someone will give a presentation and then we'll have time for questions afterwards, that sort of thing. And then we kept it at 3 tracks, and we're just thinking like Psi and Sonic would be one, and then networking software, which covers all the other software components that we're doing, and then networking hardware. So I just wanted to kind of throw it out to the meeting today, people's thoughts about that. Is that something we should keep, or do you guys feel like we should change anything?
Like, as an example, one possibility was going to maybe even creating just one of the tracks, just being total workshop, sort of, what do you call it? Like, sort of, just birds of a feather discussions where we set them up and people just sit at different tables and talk. And we could use an entire track for that. Scott, by the way, can we double just, I'm pretty sure a track room has to be set up that way for the whole day.
Could you say that again, Omar?
It has to be set up like that for the whole day. Like, we can't,
Yeah.
we have to take if we want a track like that with the round tables, it would take up the whole time.
Yeah.
One track the whole day.
Yeah. Okay. Well, not hearing much input. If you if you don't feel comfortable talking on the call, you can always just email Omar or myself, and let us know your thoughts about the format of the talks. The only other thing I wanted to just point out was in the notes there, is the timeline. So the call for participation went out last week. And then you have until November 29th at 5 p.m. Pacific Standard Time to get your abstract in. And there's a nice website they have for submitting all that stuff. And then we'll let you know about 2 weeks, 3 weeks later, which speakers are going to be on the docket. And then hopefully see you all in March at the summit.
So maybe I'll record, like by default we're gonna keep the tracks as lecture style.
Yeah.
One of the tracks, yeah, workshop stuff.
Usually for Science Sonic there is a workshop a day before, 2 days before.
Yeah, and that's being talked about. And in the past, we've had one or another company step up and host that, and we'll see if that happens, or maybe OCP will get us a room, at the convention center or someplace like that ahead of time. But that's being discussed, and it will probably also happen.
Okay.
Yeah, thanks for asking that. This is for the day of the main day of workshops. Not to be confused with the Sonic workshop we did before. Okay. All right. Maybe we can move on then to Narayana.
Sure.
Yeah, and just to set up, and I think you've got, you're presenting now, Narayana.
Yeah, that's right. And are you guys able to see my screen?
Yeah, and just to set up your talk, if folks recall, we talked about this switch back at OCP Summit earlier in the year at the Global Summit, and this was presented in one of the Facebook talks, kind of in relation to the Facebook mini pack that was covered, and it's already been that is already an OCP accepted switch, and this is Arista's switch, the 7368X4, and Arista is presenting this as an OCP inspired switch, which is, we haven't done many of these, but it's the OCP inspired designation is for a switch that has been inspired, hence the name, by one of the OCP accepted switches already, in this case MiniPack. And so Narayana will kind of go over this switch and then talk about some of the differences, but also some of the just the overall design. All right. So with that, you want to go ahead, Narayana?
Sure. Thanks, Amar. So I'm Narayanan, Surya Narayanan. I work for Arista, and I wear a couple of different hats. I work very closely with the Facebook team, Facebook network team, as well as I also work with Arista's product management team. At this point, I'm wearing the hat as the product manager for Arista 7368. Today, I have a couple of things to talk about. Brief overview of 7368, what was discussed at OCP back in March. Then jump a little deeper inside the hardware architecture for 7368, followed by how's this system different with respect to Facebook MiniPack, although they are very similar on many aspects. So go into the differences, what exists. With respect to moving further, with respect to the overview, Arista 7368, we call it a semi-fixed system because it's not really a fixed system, but it's not really a modular system overall by definition, but has a lot of aspects of a modular system. The system has a high performance capacity of 12.8 terabits using the Tomahawk 3 silicon. It has 64 megabytes of buffer that Tomahawk 3 provides. The system has been data center optimized with respect to very low power, under 10 watts per 100 gig port. It comes with a slew of features that is necessary for hyperscale cloud networking. So this could be BGP, large multicast if needed for high performance compute networks or for financial networks. It comes with very large fib tables. We call it algorithmic LPM, allowing you to program very large route table. Overall, the system has 128 ports of 100 gig, or can be configured as 32 ports of 400 gig. With respect to flexibility, the system can run Arista EOS that runs on all other Arista platforms, or can run FBOSS, Facebook Network Operating System, allowing customers to choose whatever works best for them. In this case, Facebook prefers to deploy FBOSS in roles wherever they want, or Arista EOS wherever they want, giving them the flexibility of operation, leaving the system to be exactly the same. Going into the hardware architecture. So this system has 12.8 terabits, Tomahawk 3, as I said. The modules could be 16 by 100 gig, QSFP 28, or the same module can be used as 8 by 200 gig, QSFP 56. Alternatively, a different line card could be deployed in the system as 4 by 400 gig. The system is really efficient on power and hence optimized for cloud networks. And with respect to space, it only uses 4 RU. One of the key things for this net system is it's upgradable for next generations or future platforms. Unlike a fixed system where the chassis will have to be completely replaced or the system will have to be replaced, this chassis, the supervisor, and a lot of line cards all can be retained for future systems. At this point, the system is already released and is shipping in volume to multiple customers. One of the key components of the 7368 is the switch card. This comes along with the system, and it is the base portion of the system. It uses 2U fans for cooling. We require 1900 watt power supplies to power up the system. With respect to the switch card by itself, this card is field replaceable. You don't need to unrack the entire chassis. You could just pull out this switch card from the back of the chassis, not necessary to uncable the front modules or the line cards. Similarly, the fans can be hot swapped. So this is very key part of the system, which is very different with respect to a fixed system. The switch card holds the Tomahawk 3 ASIC. The front of the chassis looks like this. It has the management module or the supervisor on the left. The line cards, the first 4 line cards that are shown here are 4 by 400 gig QSFP DD line cards. These line cards could also be an OSFP line card. The line cards on the right are 16 by 100 gig line cards. These line cards can also run as 200 gig ports, disabling the left port. So a right port on a given line card could run as 200 gig by disabling the left port. Moving further along, the rear of the chassis here shows the switch card on the top that I spoke about briefly, followed by the fan modules which are inside the switch card. So you could, as a user, pull out the entire switch card along with the fan modules. At the bottom, by default, we end up shipping with 2 power supplies, which are 1900 watts, with the provision to install 4 power supplies. For the current generation of 7368, 2 power supplies is sufficient to provide N by N power redundancy. But for future platforms, if there is a need, it provides the users to build the system up to 3800 watts and N plus N redundancy. On a high-level schematic basis, this is what a fixed system would look like, but in this case, a modular system looks very similar. Tomahawk 3 silicon sits right at the center. At the top, I have indicated here is 4 PSUs in green and 5 fans in yellow, the management card on the left, and then the line cards at the bottom. The line cards here are very unique compared to line cards that were built in previous generations. I'll come to it in a bit. Overall, the components for 7368 with respect to keeping ease of maintenance. The switch card is removable from the rear without any cable changes. Management module comes out from the front in case you need to bring down the system or upgrade the line supervisor, or it needs to be RMA'd for some reason. The 100 gig and 400 gig line cards or modules are hot swappable. The power supplies from the rear are accessible and again hot swappable. The fan modules are again individually removable and hot swappable. So overall, a semi-fixed system, but has all the aspects of a modular system for respect to ease of maintenance. Here are some of the pictures how the chassis looks like. The top left, the front view, completely empty chassis, you can see through. It's the sheet metal, if I have to say. Similarly, you can see from the rear, and with some components on the right side, where you have the switch module plus fans and blank line cards on the top right corner. At this moment, I'll pause for a second in case anybody has questions. This might be a good time to take questions, or I'll continue. Okay.
Yeah, I just had one question. When you showed the 400 gig line card or PIM card, whatever you call it, it looked like there was a gearbox on there. Does that actually have a gearbox? Yeah, the
Yeah.
GB right there.
Yeah, exactly. So the 400 gig line cards do have a gearbox. So this gearbox can operate in a retimer mode, and as well as provides the ability to break out into different port speeds. The same line card, same 400 gig port could operate as 100 gig, could operate as 50 gig if necessary, and the gearbox allows this functionality, as well as acts as a retimer to bump up the signal speeds.
Okay, so the 400 gig card can actually do other speeds besides 400 gig.
Exactly, yes.
Yeah. Okay, thanks.
Yeah, I had one question on the slide 4. I think it's the network operating system support. So if a customer was to buy this system, does it support like ONI and Open Network Linux, or how is that supported on this system?
So today the system ships with Arista EOS, and when the system boots up, just like any other Arista system, the system comes up with ZTP mode. So once the system is in ZTP mode, this allows the user to push in whatever configs they need or whatever packages they need. And this is where, if the customers wanted to deploy FBOSS or wanted to put in a specific software for FBOSS, they would use Arista ZTP to push in whatever packages they need onto the system. So the system doesn't ship with ONI at this point, but it provides ZTP using which you could push in whatever packages you need.
Okay, thank you.
Okay, I'll proceed further. Coming back to switch card specifications, I probably mentioned a couple of things already out here, but the switch card is using 50 gig PAM4 SerDes. That's what Tomahawk 3 provides, which is very different from the previous generation silicon. So this was one of the challenges overall for us moving to Tomahawk 3, is working with 50 gig PAM4 SerDes, which also pushes us to use gearbox, and that was a challenge overall for us during the development cycle. Coming to supervisor, the supervisor or the microserver, different people call it different, uses Intel Broadwell DE quad-core CPU. We ship with 32 gig RAM. By default, the system shipped with 30 gig of SSD, but provides the customers to choose in case they wanted a larger SSD system, and we could ship with 240 gig. The supervisor has a console port and management Ethernet port. With respect to management ports, there is a dedicated second port which can be used as a 10 gig SFP for out-of-band management. This was one of the inputs that came from our Facebook team as part of the joint development program, and we ended up adding here as one of the requirements. The USB ports here are used for memory devices, and then of course there's LEDs to indicate the functionality of the fan, power supply, and the system status overall. Coming back to the modules, on the top right is the 16 by 100 gig module, optionally providing 200 gig ports on alternate ports, which are the even ports. And this line card has an ejector on the line card itself to insert and remove the line card. Similar to the 100 gig is the 400 gig line cards, which comes in QSFP DD or OSFP version. And a given port can operate as 4 by 100 gig port or 2 by 200 gig. With respect to 50 gig and 25 gig on the same port, we are still working on the software to make it work at this point. Customers haven't pushed us with that feature on EOS at this point. Again, supports hot swap and comes with the integrator ejector or the handle on the line card by itself. With respect to port speeds, each port as a group of 4 can operate at different speeds. And this allows customers to use the ports as 100 gig or 40 gig to begin with today, and in future will allow customers to use a given port as 50 gig or 25 gig. And again, giving very flexible port speeds, whatever customers need. This slide out here probably talks a little more onto the gearbox. So Tomahawk 3 as a silicon provides 250 gig, 50 gig PAM4 SerDeses. 450 gig SerDes connects to a gearbox, and this gearbox takes 8 signals in. In this picture, I'm just showing 4 for the sake of simplicity, but the gearbox that we are using takes 8 signals in and spits out 16 signals. So in this picture, 4 signals of 50 gig are being used and get converted to 4 by 25 gig each, so that you can use as QSFP28 as NRZ mode, allowing a lot of flexibility. Similarly, for a 200 gig mode, this is where I was saying you could disable the alternate port, and the gearbox will convert, will just act as a retimer and just transmit all the 4 by 50 gig signals to 4 by 50 gig for QSFP56. With respect to the 400 gig QSFP DD line card, again, the entire chassis can be populated with 8 line cards, providing 32 by 400 gig ports on the system, or can be a mix and match. Again, hot swappable, very simple use, and to hot swap, you don't need to turn off the power of the system. The slide indicates OSFP, very similar to the DD as well.
Just a quick question on those previous slides. The first bullet, did you mean 32 by 400 gig?
Yes, totally. That's a typo right here.
Okay.
Spot on. Thank
Yeah.
you. Yes, that's a typo. Thank
Thanks.
you for bringing that up. Yes, I did mean 32 by 400. Going further, so while the system has been designed, joint developed along with Facebook, and the system is inspired by Facebook Minipack in multiple ways, there are differences to the Minipack. On a high level, both systems are 4RU, both systems use Tomahawk 3, both systems have similar port speeds, but there are mild differences here and there. So I'm going to call out those differences and highlight that here. With respect to dimensions, both systems are 4RU, but with respect to height, width, and depth, there's a very minimal difference with respect to millimeters out here. The 7368 is 179 millimeters tall versus 176 millimeters tall for the mini pack, and very little 2 millimeter width difference with respect to mini pack and Arista 7368. Both can mount using the 19-inch rack unit. At this point, we ship with toolless racks, and Minipack has its own rack that deploys with Minipack. However, we do have a rack adapter in case customers are interested to use the Minipack racks to deploy Arista 7368. Again, allowing feasibility to use the same rack units but deploy either of the chassis. With respect to line cards, both systems come with 16 port 100 gig line cards. At this point, Arista is planning to use the right ports to enable as 200 gig ports, whereas I believe Minipack is looking at turning on the left ports as 200 gigs. So some minor differences there. With respect to 400 gig module, fairly straightforward, 4x400 gig. At this point, we are using 2 gearboxes on this chassis on the line card overall, and in addition, we are also building a 4x400 gig OSFP line card for customers who want to deploy OSFP and are interested to deploy ZR optics in future, or higher power optics that supports more than 15 watts in future. Coming down to supervisor, this is where there was some differences with respect to supervisor and management module overall between Arista's 7368 and Minipack. Both systems use Intel Broadwell DE for the CPU. Arista doesn't deploy a COM-E or a separate module, system control module. At this point, it's a very straightforward, simple CPU on the Arista supervisor. Both systems use BMC, and both of them use the exact same chip, which is the ASPEED AST2520 BMC chip. On the Arista side, with respect to connecting to the CPU and BMC, inside the supervisor, we use an NCSI module that allows you to switch the same Ethernet port between CPU and BMC. Same thing, the front panel console can be connected to either the CPU or BMC at a given point of time, and this is where the NCSI switch again comes into play. The front panel USB is only for memory devices. While I indicate all these things about 7368, on the Minipack side, there are a bunch of differences here. Minipack has an out-of-band gig switch for COM-E and BMC inside the Minipack chassis or inside the supervisor module. Similarly, there is a front panel console to the BMC, which is different from Arista. And finally, the USB port on the Minipack supervisor can be used as a diagnostic port or a debug port. And these are some of the differences with respect to both these systems. In addition, going back into power supply units, Arista deploys a 1900 watt. We can also call it a 2000 watt. I don't know why is that named that way, but we use a Delta DPS 1900 AB power supply unit. This is a standard power supply that can be purchased from Delta. With respect to Facebook Minipack, it uses a Bell Power power supply unit, which is a 1500 watt. Power plane, at this point with 7368, it could be just 1+1, just for redundancy. Obviously 2+2 will provide more redundancy, but 1+1 is good enough. For Minipack at this point, you need 2+2 power supplies to make it N+N redundant. The Delta power supply, at this point, the input is between 200 and 240 volts AC or 40 to 72 watt DC. There's some differences with respect to the Bell power supply here. Fans, again, some differences out here. Arista uses a single rotor fan, which is 80 by 80 by 38. These are small fans, and we use 5 fans, versus the Minipack uses 80 by 80 by 80, and these are counter rotating fans, and they use about 8 fans in total. Coming to gearbox was really a necessity for pretty much all 50 gig PAM4 silicon devices in case it had to operate in 100 gig mode. And this is where Arista chose to deploy Credo CRT50216 gearbox PHY. This could also act as a gearbox or a retimer. Similarly, Facebook deployed Broadcom BCM 81724 gearbox PHY. With respect to further differences, another key difference between Arista's 7368 Minipack was how is the Tomahawk 3 mapped to the front panel ports. This could mean how much buffer you get on a given port is different with respect to on a pair of ports is different on Arista versus Minipack. So I have laid out here the complete mapping on which front panel ports are connected to which ports on the Tomahawk 3 silicon. Similarly, I believe Minipack has shared its spec as well and submitted to OCP, which would indicate what are the differences between the two systems. So this by itself, for an end user, using the same port, assuming the same buffer between Arista and Minipack would not be smart. So one would have to look into which ports are connected to which pipes, which ingress pipes and which egress pipes, to understand how much buffers are available for a group of ports together versus on the Minipack. Similarly, we'll have to go through the same exercise to make sure they're using the same Tomahawk 3 SerDes mapping to front panel ports. This slide again completes rest of the ports for the 128 ports of 100 gig. Right? This is what I had so far. Do you guys have any other questions?
Yeah.
By the way, just to thanks, Ariane. I just wanted to say a couple of folks also from the Facebook team, Alex and Shu, are on the line as well to help answer any questions. But you've obviously gone through the presentation for the Synergy 68.
Is the buffer in the Tomahawk segmented into separate forwarding processors, or is it a unified buffer?
The forwarding is one single system. I can look at that, but the buffer is divided into two ITMs, and it is divided into 32 megabytes of buffer. So depending upon the ports, a given port can be part of a given ITM, and so it would have access theoretically to the 32 megabytes. In addition, that 32 megabytes is divided into a quad. So depending upon the given ingress pipe and egress pipe, the buffer will further get split in that 32 megabytes. So it's, while from a forwarding perspective, it's all single chip, from a buffer perspective, it's been divided into ITMs, divide by 2 basically. Further down, divide by ingress pipe and egress pipe, which is divided by 4 at that point. So probably Shu is also an expert here. Shu might be able to share something here in case Shu wants to add.
No, I'm not sure whether Broadcom would like to share all the details. My understanding is certainly ITM is 32 megabyte memory size limit, but regarding each specific queue, the maximum buffer size, Broadcom has its own buffer management rules about, and certainly it is also user configurable.
Thanks.
I had a couple questions about the BMC, and I was curious, first of all, is that going to run OpenBMC like the Minipack?
In FBOSS mode, yes, it would run OpenBMC just like the Minipack, very similar to the Minipack. In case of Arista EOS, it would be a pass-through mode. At that time, it will not be running OpenBMC.
Okay. And then you mentioned some sort of switch that allows the front panel ports to either, connect to the console of the BMC or the console of the Intel CPU. How does that switch work? I didn't quite understand that.
Sure. So this is not the front panel ports. This would be on the supervisor by itself. Inside the supervisor, you have the Ethernet port as well as the console port that has to connect either to the CPU or to the BMC. So this would be a very simple NCSI switch that sits inside the supervisor, allowing to flip the connection between, if you want to connect the console to the CPU or to BMC. So you could change some registers, which will basically, you could call it as direct all the packets towards the CPU or to the BMC. Versus,
Okay.
and this is where Shu can probably explain a little more what happens on the mini pack side. There's probably a little more flexibility on that side.
Yeah, so on the mini pack side, there is a simple layer 2 switch that connects the CPU management port, the BMC Ethernet port, and the front panel Ethernet port. So essentially, it's one layer 2 network.
Okay, so then on the Arista switch, do both the BMC and the Intel CPU have access to this register that flips the like the console from one to the other?
I believe so, yes.
Okay.
So at a given point, you could only be talking to one or the other, not both. Versus in case of mini pack, you could literally be talking to either of them at the same point of time.
Right. Okay. Thanks.
Any other questions?
So just a point of clarification: is the Arista product being considered for OCP inspired based on the Facebook mini pack specification, or is Arista submitting their own specification and then having the actual product become inspired based on Arista's specification?
This would be based on the Facebook mini pack specification.
Okay.
Yeah. So just to clarify, Jeff, the idea, at least we haven't done many inspired, but to try to see how to go about this. So the contribution package that you see online has the data sheet, and it has a specification that talks about the differences between, that Narayan's already gone over, but in more detail, the differences between the mini pack and the 768. And again, just for clarification for folks, an OCP inspired switch doesn't need the full design package.
Right, but the
It's
actual
the
specification that this product is inspired by is the already accepted mini pack specification, and the specification that Arista is putting forward is more informational than having to be accepted. Is that correct?
In particular, it doesn't have to go through the accepted process or the same accepted process, but it does need to show the differences.
Yes. Okay, I understand. Thank you.
Yeah. And again, this is a little, just for everybody, this is a little bit new for us since we've only done a couple of the OCP inspired before, and this is one. In the past, when we've done OCP inspired, it was truly the identical switch, just with nearly identical switch. This is one where there are a few more differences, but it is jointly specified and based on the mini pack. All right. Any other questions?
I'll just comment. Very good. I'm glad to see you guys at Arista involved. Congratulations.
Thank you so much. It was a wonderful 18-month program between the Facebook team and the Arista team, and it was a pleasure working overall at the fast pace as well as building next generation systems. It was really a great experience overall. And glad to see this is coming to be shared as OCP inspired now.
Great. So Narayan, thank you very much. I think, and then we'll follow up with, kind of next steps with how to. Now we've gone through this review. If there are other further comments, then we'll follow up on next steps with this to kind of get this in front of the incubation committee.
Excellent. Thanks, Kumar.
All right. Thank you. All right. So I think that's it for the first two. We went over Global Summit. We went over the 7368 from Arista Networks. Scott, do we have anything else on the agenda for today?
That's all I had. We can throw it open if anyone else had something they wanted to bring up. Now would be a good time to do that.
Was there an October meeting, and is the recording for that available?
Hey, Jim, I can barely hear you there. There's a lot of background noise.
Yeah. Was there an October meeting, and is there a recording of that meeting?
I believe there was a October meeting, and I will try to dig up a recording of it and get it posted on the wiki.
Great, thanks.
Okay.
All right. So we'll follow up on the contribution, 7268, and then as a reminder to everybody, get in your talk proposals for OCP Summit. Those are due in just over a couple of weeks, and the link to submit a talk is in the notes. Hope we see a lot of contributions or submissions for talks, as we always have. And we'll follow up. We'll probably, let's see, December, the next meeting. Yeah. Scott, Shin, and I will be kind of going through all the submissions that week or two after the deadline, and then we'll probably have some insight into that by the next call. All right. Thank you all very much.
Thanks, everyone. Bye-bye.